Hello all, we are starting Unit 6, Trigonometry of Right Triangles in this lesson, and we are going to start this by looking at our good friend Pythagoras and his theorem. So, note, just recalling what our Pythagorean theorem is and what it entails. So a right triangle is a triangle that has one right angle. We will never have two right angles in a triangle because there are only 180 degrees in a triangle, and if I have two right angles, I have 180 degrees, and I only have two angles, and it's not a triangle, and it makes no sense. So we have the side opposite the right angle is the longest side, and it, of course, is called our hypotenuse, and the other two sides are called legs. So you will sometimes see them called arms, but I will not be calling them arms. I will be calling them legs. Our triangles here will be armless. So our Pythagorean theorem is the formula that states the relationship among the sides of a triangle. And as you might recall, it is a squared plus b squared equals c squared, where a and b are legs, and c is our hypotenuse. So in order to use this formula, we have to make sure that we do have a right triangle. So there has to be a 90-degree angle in order to use it. And that 90-degree angle is always across from our C side. Okay, so the C here. Now, if we take a look here, how I label the other ones, now it doesn't matter what you really have as A and B, but if you do have a triangle made for you, you should be, for example, this is A, here is B, and you will notice that side A, little a, is across from angle A, just like side little c is across from angle big C, and side little b is across from angle big B. And you will always do this. For example, you won't have A here and B here if these are your A and B angles. Okay, now we'll just leave a note for ourselves with that. So our vertices, or angles, we have labeled with capitals. And our sides, we have to go across from our angles. And they are lowercase. Oh, bad writing. Okay, so our first example. So we're going to find the unknown lengths, and we're going to round to 1 decimal. Now, here's my unknown length, and it is across from side B, or angle B, so it will be side B. Little b, there it is. Okay, so writing out our formula, a squared plus b squared equals c squared. Now, there's two ways to do this. One way is to just substitute in right now and solve. The other way is to solve for your variable, and then so isolate your variable, substitute in, then solve. It doesn't matter what you do. I will do both in this lesson. So let's just substitute in and then solve for this first one. So here, this is B. Here I have A, and here my hypotenuse, my longest side across from my 90-degree angle, is C. So my hypotenuse. So A is 8, so 8 centimeters squared plus B squared, not 6, equals C squared, so 10 squared. So 8 squared, 64, plus B squared equals 100. Now solving for B squared, we need to get rid of this 64, so it's like plus 64, so minus 64 from both sides. And I get b squared equals 36. And lastly, I need to get rid of the squared, so inverse operation, square root gets rid of my squared there, and the square root of 36 is 6. So b equals 6, and don't forget our units of centimeters. So b equals 6 centimeters. Okay, so that's substituting in right away, and then solving as we go. For this one, we will isolate our variable first, and it's not going to be very hard. Okay, so a squared plus b squared equals c squared again. Okay, so here's a, here's b. Once again, it doesn't really matter if you mix up your legs. The important thing is to get our hypotenuse in the right place, but we will be, since it's ABC anyway, we will make sure that we put our a in as 19.8 and our b in is 9.5. Now this is really easy to solve for, so we're solving for c, and the only thing that's on c's side is a squared, so we will just square root, and you have to square root the whole other side. Okay, so this gets rid of that, and I get the square root of a squared plus b squared will be c, and I'm just going to move c over here. So c equals the square root of a squared plus b squared. Now you can't just cancel these squareds out, and I'll get to that in a minute. We have to make sure that we are square rooting the whole side. Okay, so square rooting the whole side of a squared, which is 19.8, squared plus b squared, which is 9.5 squared, and then square rooting that whole thing. So 19.8 squared, we get 392.04. 392.04 plus 9.5 squared, which is 90.25. And we square root that after we add them, so adding those two numbers together, and we get 482.29. And lastly, square rooting that number, we get 21.9611, so on and so forth. And lastly, we need to round this to 1 decimal place. So taking a look here, this is where we will cut it off after 1 decimal place. Take a peek over the wall. We do need to round that 9 up to a 10, which means this will be 22 centimeters. 22.0 centimeters to be precise. One of the most common mistakes here is to forget to square root at the end here. So here, instead of square rooting for the 36 and getting 6, is just to leave it as 36. Don't forget, you always, for solving for any of your sides, will need to square root at the end. Okay, next example. So looking for A, here we have B, and across from our right angle, we have our longest side, our hypotenuse, which is C. So a squared plus b squared equals c squared. So a squared, we do not know, and let's just put it right in this time. So b squared, 6.3 squared, and equals 12.6 squared. Okay, so then math, got to do our exponents first. So there is no brackets, exponents. So a squared plus 6.3 squared, which is 39.69, equals 12.6 squared, which is 158.76. Now taking a look, this is added on, this 39, so I will have to subtract it off. So subtract 39.69 from both sides. Okay, so it gets rid of that there. We get a squared equals 158.76 minus 39.69, which is 119.07. Now we are not quite done because this is a squared, not a, so I will have to square root it. So that gets rid of my squared on that side, and I get a equals the square root of 119.07, which is 10.9119, so on and so forth, or to 1 decimal place. Be cutting off after the 9, take a peek over, and I will not be rounding this 9 up, so it will just be 10.9 and centimeters. Okay, in the second example, I said that I want to talk about why you can't just square root this and get a plus b equals c. One of the nicest ways to do this is to actually think of an example of a Pythagorean triple, so whole numbers that will give you an a, b, and c. So 3, 4, and 5 are the smallest example of a Pythagorean triple. So 3, 4, and 5. And I can check that 3, 4, and 5 give me a right triangle by plugging them into my formula and seeing if a squared plus b squared does in fact give me c squared. So a squared, so 3 squared plus 4 squared, does that give me 5 squared? So 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25. Aha! So 25 equals 25. It does work, so I know that this will be a right triangle. This will have a right angle. So why can I not just square root the whole thing? These things are all squared. Why can't I just square root it? So we aren't going to go super in depth into the math, but we are going to use this example of a right triangle that we know to show that a plus b does not equal c, which is why you cannot just square root the whole thing. So a is 3, b is 4, c is 5. Does this work? So 3 plus 4, I guess 7. And 7 does not equal 5. This does not work. You can't do this. Do not just square root everything. Okay. Answer, no. So taking a look, the area of B and the area of A add together to give us the area of C. Conversely, if you know the area of C, it will divide into giving you A's area and B's area, but not A and B themselves. Okay. So C squared equals A squared plus B squared, or A squared plus B squared equals C squared. Next example. So John leaves school to go home. He walks 6 blocks north, then 8 blocks west. How far is John from the school? In blocks, obviously. Okay, so here's John at school. Here is John at home. Now, we want a straight line distance from the school, not just adding our 6 blocks plus our 8 blocks. We want to know exactly how far a distance he is. So we are finding our hypotenuse. Now, it doesn't matter which is A, which is B. Let's say A and B. So what's important is we have our hypotenuse is C, and that is what we are solving for. So A squared plus B squared equals C squared, and just substituting into our formula. So A we said is 8, B we said is 6, and then we want to find out what our hypotenuse is. So 8 squared, 64, plus 6 squared, 36, equals our hypotenuse squared. So 64 plus 36, we get 100. And lastly, we just need to square root that. Last step, always a square rooting, and we get square root of 100 is 10 equals C. Now we should probably have a unit here, so it is not just 10, 10 wood, 10 blocks. And since this is a word problem, we should write a sentence. So John is 10 blocks from the school. Okay. Okay, our last example, we have a 13-foot ladder. Holy bad grammar, Batman, is placed 5 feet away from a wall. The distance from the ground straight up to the top of the wall is 13 feet. So from the ground to the top of the wall is 13 feet. Will the ladder reach the top of the wall? Now, you could do the math here and figure out, okay, here we want to know how tall it reaches. Does it reach 13 feet? Or you could recognize that, okay, if I need it to reach 13 feet up, then I can't have my 13-foot ladder be 5 feet away from the wall. I'd have to have it straight up against the wall, which is highly unsafe for climbing up, which you would not do. You always want it to be a certain distance from the wall. So since my 13 feet is my hypotenuse, and my hypotenuse is the longest side, then I know without doing any math that this is not going to reach the very top of the wall. So no, 13 feet is the hypotenuse. Which is along the side. So it won't reach 13 feet up the wall. Because that is a leg. All right. Now, before I send you on your way, I need to just talk about a couple other things. So sneaking back in your assignment, there is going to be some questions about using some terminology. So here from A to B, this is like slanted. So this is your diagonal. Maybe write this on your note sheet. Here is horizontal. Think of the horizon. Okay. Horizon. Look at the sun coming up. So horizon, horizontal, and here straight up and down, this is vertical. Okay, so you need to know those. And lastly, on your assignment, I don't know why, but it printed off without these answers in. So you might want to just get those copied down or check once you're done. So 22 to 26, these are your answers. Okay,